SOLIDWORKS has many pre-made cuts you can use when designing sheet metal parts. You can find these cuts in the Design Library section of the task pane. You will find a folder called Features and a subfolder called Sheet Metal. As with anything from the Design Library, all I have to do is to drag it onto the part. As soon as I take my finger off the mouse, the property manager for this feature appears. You can use the Edit Sketch button to further define the location of the cut. And you can click the Override Dimension value to change the size of the cut. Once you've made the changes you need, click OK, and the feature is added. Using the Design Library is useful for any type of design, but it's especially useful in sheet metal design where the same cuts are constantly repeated. For instance, if you design computer cases, you likely will have to create standard cutouts for USB or Ethernet connectors. We have already seen the Design Library is a great place to find pre-made cuts, but it is also a great place to find forming tools. A forming tool is used to bend, stretch, or otherwise deform a sheet metal part. You can find a collection of forming tools in the Forming Tools folder of the Design Library. Let's take a look at how to add one of these features to a sheet metal part. From the Embosses folder, I'll drag the dimple feature onto a face of my part. Watch as I drag the dimple. I can see a preview as I drag across the faces of my part. The default direction is to go into the face I drag it onto. To change the direction of the feature, I can hit the Tab key on the keyboard before I let go of my mouse button. Once I let go of the button, I can't switch the direction. I would have to delete the feature and insert it again. As soon as I let go of the mouse button, I get a dialog that prompts me to locate the feature using sketch tools like dimensions and geometric relations. Once you've made your changes, click the Finish button. Now you can see I have added a dimple to the part, and the Feature Manager now shows the dimple feature. If I later need to move the dimple, I can edit the placement sketch that is underneath the dimple feature in the feature tree. If I want to edit the actual dimensions that make up the library feature, such as making the diameter of the dimple larger, I'll first need to permanently break the link that the dimple has to the library feature, represented here with an external reference arrow. I'll edit the dimple feature, and under the Link group box, I'll uncheck the Link to Form tool option and click OK. The arrow disappears, and I can now double-click the dimple feature from the tree, and then double-click on the diameter dimension to change it. Forming tools permanently deform the part. Watch as I click the Flatten button. The dimple still exists in the flat pattern. Forming tools are very easy to use. All you have to do is drag and drop them from the Design Library onto your sheet metal. That is, assuming SOLIDWORKS knows you're using a forming tool. When I drag and drop this forming tool onto this sheet metal part, you can see right away SOLIDWORKS asks if I'm trying to create a derived part. Before I show you the quick way to get rid of this message and make it work, I'd like to explain to you why SOLIDWORKS is telling me this. I'm not trying to make a derived part, so I'll click No. But instead of punching into the sheet metal like I want to, the part simply opens up in its own window. That's because SOLIDWORKS isn't recognizing this particular part as a forming tool. It's treating it as a regular part. Notice if I go to File, Save As, I can choose Form Tool from the Save As Type drop-down menu. I'll give this a new name and save it back to the Design Library. Now I can look for the form tool we just saved, and when I drag and drop it onto the part, you can see SOLIDWORKS is treating it as a forming tool like I want it to. I can position the sketch, add dimensions, and when I click Finish, the tool creates a punch in the part. Now, you might be thinking it's going to be a pain in the butt to open up all the forming tools individually and resave them all as form tools instead of parts. As I mentioned before, I wanted to explain why you were getting the error before I showed you the quick fix. To set the whole folder to open as forming tools all at once, I can simply right-click it in the Design Library and choose Forming Tools Folder from the drop-down menu. Now, when I drag and drop any of the forming tools from this folder in the Design Library, SOLIDWORKS will automatically recognize that they're form tools, and I won't see that derived part message again. If the forming tool you need does not exist in the Design Library, you will have to create it. You can start from scratch, or you can edit an existing forming tool that is similar to the one you need. In this lesson, I'll edit the bridge lance from the Lances folder. All I have to do is right-click it from the Design Library and choose Open. It will open in its own window, and you can see that it is just a part. Notice that the part has yellow and red faces. The colors are very important. The red color tells SOLIDWORKS that these are the faces to remove once it is inserted into a part. As I use the rollback bar in the feature tree, you can see how the part was created. A base was made first, and then the geometry of the bridge lance. At the end, the base was cut away and a sketch was added. This sketch is used to position the feature when it is inserted into a part. I will edit the sketch of the boss extrude and change it to have only one angle face. Once I exit the sketch and the part rebuilds, there will be errors on the fillets because of the changes I made. I will edit the fillet feature and let SOLIDWORKS remove the non-existing edges. Once the errors are repaired, I will add the red color to the new flat face I created. Once again, the red color tells SOLIDWORKS to remove this face from the target part. Rather than manually changing the color of the face, I can use the Form Tool feature to have SOLIDWORKS do this for me. You will find the Form Tool feature under Insert, Sheet Metal, Form Tool. The feature does three things for you. It defines a stopping surface, defines faces to be removed, and automatically creates an orientation sketch to help position the forming tool. The stopping face determines how far the forming tool will be pressed into the sheet metal. In this case, the stopping face is this one on the bottom, and the faces to remove are these flat ones. I'll click OK, and you can see the face color has changed to red, and the stopping face is shown in cyan. In the Property Manager, you see the Form Tool feature has been added along with an orientation sketch. My editing is complete, and I will do a Save As from the File pull-down menu. I will save it in the same folder as the original part. It is important to do a Save As instead of Save, or you will overwrite your original bridge lance. I'll give this new forming tool a new name, click the Save button, and close the part. When I browse to the Lances folder of the design library, I can see the new forming tool I created. The preview of the forming tool comes from the view of the part that was on the screen when I saved it earlier. I can now drag it onto my sheet metal part and use the Tab key to change its direction. Next, turn the feature 90 degrees. I'll type in 90 degrees and press Enter to rotate the sketch. This is the only change I'll make, so I can click Finish to complete my custom forming tool. As I mentioned in the previous lesson, the easiest way to make a custom forming tool is to modify one that already exists. In case you don't find one close to what you need, let's take a look at creating one from scratch. As we create the forming tool, keep in mind that the minimum radius of curvature used in the forming tool must be greater than the thickness of the sheet metal part it is being applied to. This will prevent sharp corners from appearing after a forming tool is used. Here I have a new part. I'll begin by creating a block on the top plane to use as a base. Using a base like this will enable me to create fillets that will show up in the sheet metal part, as we'll see a bit later. Now that I have a base, I'll create the geometry that will define the forming tool. For this example, I'll be using a slot. I'll begin my sketch here on the face of the block. To quickly create the slot shape, I'll use a center point straight slot, centered on the origin. I'll add a few dimensions. Now I'll extrude the sketch to give this forming tool depth. Notice the sharp edges. These would cause trouble when punched into the sheet metal, so I'll round them out using fillets. Remember that the minimum radius of curvature of the forming tool must be greater than the thickness of the sheet metal part you intend to use it on. So if I'm going to use this on a sheet metal part that is 60 thousandths thick, I need to make sure my fillet radius is greater than 60 thousandths. Once the fillets are in place, you can get rid of the base feature if you wish. By doing so, you can simplify the forming tool and make it easier to identify when you use it later. Before I cut away the block, notice that it would be impossible to create this fillet without the use of the base. That is why it was created in the first place. An easy way of cutting away the base material is to start a sketch on this face and use the Convert Entities sketch tool. I'll create a through all cut, and all material above the top plane is completely removed. In addition to stamping this shape into the sheet metal part, I also want this forming tool to create a round hole. In order to do this, I have to color a round face red. Unfortunately, I don't have a round face to color, so I'll have to create it. To create the round face, I'll have to use the Split Line feature. I'll start a sketch and create the shape I need. A simple circle. Next, I'll activate the split line command from the Insert Curve drop-down menu. I'll select the face to split and specify a single direction. When I click OK, a new round face has been created. Keep in mind that split line doesn't create a cut, it simply separates a face, so you can do things like apply a color, which is what I need to do here. Now that the geometry of the forming tool is complete, I can use the Form Tool feature to define the remaining parameters of the forming tool. I'll select the bottom flat face as the stopping face, the round face as the face to be removed, and click OK. Notice the orientation sketch was automatically created. To be able to use this new forming tool, we now have to put it into our design library. The easiest way to do this is to drag the file into the Forming Tools folder. Be sure to use the push pin to keep the task pane open. All you have to do is give it a name. Notice the preview image displayed in the design library is the view that was on your screen when you saved the forming tool. If you wish to update the image, rotate the forming tool into the desired view, then drag it into the design library again, overwriting the existing file. Now that the tool is complete, I can test it on a sheet metal part. I will drag it from the design library and drop it on the face of the part. This is where the positioning sketch is useful. I can dimension to it, create relations, whatever is necessary to locate the forming tool. I'll click Finish, and the forming tool is applied. SOLIDWORKS provides you with a whole library of forming tools that let you create form features in your sheet metal models. In this lesson, we'll take a look at creating a custom forming tool to use with this part. I'll start by creating a new part file and set the units to IPS to match the sheet metal part units. But because this is just a forming tool, I won't define a part material. First, I'll create a block on the top plane to use as a base. This feature will allow me to apply a fillet on the edge of the forming tool. Next, I'll create a 1-inch diameter circular extrude on the top face. With a blind depth of 1/2 inch and a draft angle of 15 degrees. Next, I'll fillet both the top and bottom edges of the feature with a radius of 0.125 inches. It's important to remember that when you're adding fillets to forming tools, the minimum radius of curvature must be larger than the thickness of the sheet metal part that it will be used on. Next, I'll create the hole in the forming tool. First, I'll start a new sketch on the top face and create the sketch geometry. Next, I'll add sketch relations and dimensions to fully define the sketch. With the sketch complete, I'll use the split line feature to create the face that will be removed from the forming tool. In the Sketch to Project window, I'll select the sketch I just created. And in the Face to Split window, I'll select the top face. I'll click OK. And you can see the face was split. Next, I'll remove the base using a Cut Extrude feature. I'll start a sketch of the top face of the block, use the Convert Entities tool to create the sketch geometry. I'll set the end condition to Through All, and the geometry is complete. Next, I'll use the Form Tool feature to define the properties of the forming tool. I'll choose the bottom face of the feature as the stopping face, and the center of the top face as the face to remove. I'll click OK, and the forming tool is complete. I'll save the part by dragging it into the Forming Tools Design Library folder. And the forming tool is ready to be used on the sheet metal part. To add the forming tool to the sheet metal part, I'll open the Forming Tools folder from the Design Library, select the forming tool I just created, and drag it onto the bottom surface of the part. As a quick side note, if you have any trouble placing the forming tool onto the surface, or if SOLIDWORKS asks you if you intend to create a derived part, make sure the folder you saved the forming tool in is saved as a Forming Tools folder. You can set any folder as a Forming Tools folder by right-clicking it and selecting Forming Tools folder. Under the Type tab of the Property Manager, I'll make sure the forming tool is going in the right direction. Next, I'll use the Position tab under the Form Tool feature options to create 4 instances of the feature and dimension them to be 1.5 inches from each edge. I'll click OK, and the dents are created.